Welcome to a video that will show how to determine the curvature of a curve defined by a vector valued function. The curvature at a point measures how sharply the curve bends or how quickly it changes direction. And just for reference, the curvature of a line would be 0 since a line does not bend, and the curvature of a circle would be equal to 1 over r, or the reciprocal of the radius. So if you think of a small circle, it turns or changes direction very quickly compared to a very large circle, so the reciprocal of a small radius would be very large, and the reciprocal of a large radius would be very small. More formally, the curvature measures how quickly the direction of the unit tangent vector changes with respect to the change in arc length. So the curvature is equal to the magnitude of dt ds expressed in either way here. Notice this requires that the unit tangent vector function be defined in terms of s, or arc length. Before we take a look at the formula we're going to use in this video, let's take a look at curvature in action. What we're seeing here in this video are the unit tangent vector, unit normal vector, and this blue circle represents the radius which would be used to determine the curvature. Remember, the curvature would be 1 divided by the given radius of the circle. So if we approach the bend in this curve, we expect the curvature to increase, or the radius of the circle to decrease, as we see here. Again, remember, the curvature would be 1 over r, where r is the radius of this blue circle. Again, as we approach this next bend or curve, the radius decreases, increasing the curvature, and so on. Let's go and take a look at one in 3D. Here the unit tangent vector is the red vector, the unit normal vector is the blue vector, and this light blue circle would be used to determine the radius, where the curvature would be 1 over r. Again, as we approach the bend, you'll notice that the radius of the circle decreases, and as the curve straightens out, the radius increases. Let's go and take a look at the formula that we're going to use to determine the curvature of a curve. So again, here we're measuring the change in the unit tangent vector with respect to arc length, and then determining the magnitude of that. Using the chain rule, we could perform substitution to come up with dt dt divided by ds dt. Remember, dt dt would be the derivative of the unit tangent vector valued function. Now ds dt would be the velocity vector valued function, and remember that v of t is equal to r prime of t, so that's where this comes from. There's also another formula that we can use to determine curvature, as we see down here below. This alternative formula is helpful because remember that sometimes determining the derivative of the unit tangent vector valued function can be very messy, and if that's the case, we might want to use this alternative formula. We'll do one using this formula, and we'll do another example using this second formula. Let's determine the curvature of r of t equals 2 cosine t, comma 2 sine of t. In order to use this formula here, we first need to find the unit tangent vector valued function, or t of t. So the derivative of 2 cosine t is negative 2 sine t, and the derivative of 2 sine t would be 2 cosine t. We'll go ahead and divide this by the magnitude. So we'll have the square root of 4 sine squared t plus 4 cosine squared t. Let's go ahead and simplify this. If we factored this radicand, we'd have 4 times sine squared plus cosine squared. Well, sine squared plus cosine squared is equal to 1, and the square root of 4 would be 2. So we'd have 2 here. We could also factor out a 2 from this vector valued function. We'd have 2 times negative sine t cosine t. This simplifies nicely, so t of t is equal to an x component of negative sine t and a y component of cosine t. Let's go ahead and find the derivative of this vector valued function. The derivative of negative sine t is going to be negative cosine t, and the derivative of cosine t is negative sine t. Okay, we're almost there. Looking back at the curvature formula, we need to determine the magnitude of t prime of t, and then we also need to determine the magnitude of r prime of t, which is here. So the magnitude of t prime of t is equal to the square root of, this would be cosine squared t, plus, this would be sine squared t. Well, that's going to be equal to the square root of 1, which is equal to 1. And now we need the magnitude of r prime of t. It's going to be similar. We have the square root of, well, negative 2 sine t squared is going to be 4 sine squared t. And 2 cosine t squared is going to be 4 cosine squared t. Well, if we factored out the 4, we'd have 4 times sine squared plus cosine squared. That's going to give us 1. So we have the square root of 4 times 1, the square root of 4, which is equal to 2. So the curvature is equal to 1 divided by 2, or 1/2. And going back up to our vector valued function, where the x component is 2 cosine t and y is equal to 2 sine t, if we convert that to a rectangular equation, it's going to be x squared plus y squared equals 4. So we have a circle with a radius of 2. Remember, if the circle has a radius 2, the curvature would be the reciprocal, or 1 over 2. And this just confirms what we said before, that the curvature of a circle is the reciprocal of the radius. Let's go and take a look at another example. So before we decide on a formula, we're going to go ahead and try to determine the unit tangent vector valued function, and then see how difficult it is to determine the derivative of that. So t of t would be equal to the derivative of r of t divided by its magnitude, so we'll have 1 for the x component. Derivative of t squared divided by 2 would be t, and the derivative of t cubed divided by 3 would be t squared. Divided by the magnitude, which would be square root of 1 squared, or 1, plus t squared squared, or t to the 4th. Now looking at this vector valued function, it would be pretty messy to determine the derivative of this vector valued function. So in this problem, let's go ahead and use the alternative formula for curvature given by this formula here. So to help us out here, remember this was r prime of t divided by the magnitude of r prime of t. And the reason I mention that is we're going to need r prime of t crossed with r double prime of t. Let's go ahead and write that over here. R prime of t has components 1, t, and t squared, and r double prime of t would be 0, 1, and 2t. So to use this second formula, what we're going to have to do is cross r prime of t and r double prime of t, and then find the magnitude, and then divide that by the magnitude of r prime of t raised to the 3rd power. Remember, this cross product would be the vector formed by the 3 by 3 determinant, where the first row is I, j, k. The second row would be 1, t, t squared. Third row would be 0, 1, and 2t. So this first 2 by 2 determinant will be formed by eliminating row 1 and column 1. So we'll have t, t squared, 1, and 2t. Here we're going to eliminate row 1, column 2, so we'll have 1 t squared, 0, 2t. And here we'll eliminate row 1, column 3, we'll have 1 t, 0, 1. So the result would be 2t squared minus 1t squared, that's t squared. Here we're going to have 2t minus 0, but there's a minus sign here. It's going to be negative 2t for the y component. And here we're going to have 1 minus 0, so the z component will be 1. Okay, now that we have the cross product, we need to find the magnitude of this, and that's going to be our numerator. And then we need to find the magnitude of r prime of t and raise it to the 3rd power for our denominator of the curvature. So let's go ahead and take that information on the next slide to finish this up. Okay, so here's our formula. Here's the cross product that we just found. Here's r prime of t. Let's go ahead and find the magnitudes now. So t squared to the 2nd will be t to the 4th. Negative 2t squared will be positive 4t squared plus 1 squared, or plus 1. And then for the magnitude of r prime of t, we're going to have 1 squared, or 1 plus t to the second, plus t to the second squared. It'll be t to the fourth. To finish this up, we know we want the curvature when t is equal to 1. So our numerator is going to be the square root of this when t is equal to 1. So we'll have 1 to the fourth plus 4 times 1 plus 1. That's going to be the square root of 6. Remember, our denominator here is cubed. So the square root of 1 plus 1 squared plus 1 to the fourth, that'll be 3. It's going to be the square root of 6. Now the square root of 3 to the third is going to be 3 square root of 3. Again, we can simplify this. Remember, this is the square root of 2 times the square root of 3. All over 3 square root 3. This simplifies out. So our curvature is going to be equal to square root of 2 over 3. And it's probably good to get a decimal approximation for that. It's approximately 0.47. And that's going to have to do it for this video. I hope you found these two examples helpful.